Okay. أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم رب اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقهوا قولي ربي زدني علما وارزقني فهما. Assalamu alaikum wa rahmatullahi wa barakatuh and good evening. And Aibon Vanakkam. Okay, fine. We'll start the class, right? So today now we are going to start regarding the frictional force. Try to get the idea. First of all, I'm going to explain all the things related to the frictional force. And these are the questions which are related to frictional force. So you can take note within the paper, in your last page of your question paper, you have taken the printer, right? So in that paper, you can mention this one. These are the questions: 4, 8, 19, 27, 33, 44, 53, 54, 55. So these are the questions related to the frictional force. So in your paper, you can mention these things, because when I revise in the paper, it will be easy, right? You may remember earlier we had discussed what are the questions under the momentum, what are the questions related to the displacement diagram, like that. So today also we are going to discuss in the same pattern. So frictional force, these are the questions related to the frictional force. Okay, question number 4. First of all, I'm going to explain the frictional force. For example, just say if you want to move this box, what will you do, Bulal? I had taken a box, right? Okay. So now I'm going to move this box. So first of all, we apply 1 Newton. When you are applying 1 Newton force, the frictional force also will be 1 Newton. So the 1 Newton and the 1 Newton will be balanced. So the object will never move. So what will you do, Plehal? You will increase the force up to 2 Newton. Same, 2 Newton. The frictional force also has been increased up to 2 Newton. So 2 Newton got cancelled. Then after what will happen? You will increase the force little by little. When you are applying 3 Newton, the frictional force also will apply, increase up to 3 Newton. So the object is not moving. Then what will happen? You will apply another 4 Newton. 4 Newton. When you are applying 4 Newton, the frictional force also will be 4 Newton. So what will happen to the object? Still the object is not moving. And when you are applying 5 Newton, still the object is not moving. So like this, you are going to increase the force little. 6, 7, 8, 9, 10. Now what happened, Bulahal? When you are applying 10 Newton, now what happened? The object will just starts to move. It will never start. It will never move. It will just begins to move. So here earlier they were applying 7 Newton, then 8 Newton, 9 Newton, 10 Newton. When you are increasing the force like this, along with our force, the frictional force also will increase. But when I am applying 11 Newton, now the frictional force will never increase up to 11, because the frictional force has a limit. So up to 10 Newton, the frictional force increased. But when I am applying 11 Newton, now what happened, Pulal? Now I am applying 11 Newton. But the object cannot apply 11 Newton because the frictional force has a limit. What is the limit, Pulal? That is 10 Newton. Earlier, when I am applying 9 Newton, it gave 9 Newton. When I am applying 8 Newton, they gave 8 Newton. But when I am applying 11 Newton, the object cannot give 11 Newton because the frictional force has a limit, that is 10 Newton. Now, what will happen to the object? Can anyone tell whether the object will move or will be at the rest? Anyone? Whether the object will starts to move or whether the object will be at rest?
Starts to move.
Starts to move, very good, because here we have applied 11 Newton. Here we have 10 Newton in left hand side. So we won the match because 11 Newton is more than 10 Newton. So what will happen to the object? Well, they starts to move. They starts to move. Right. Now, Pulahal, 12 Newton. If I'm applying 12 Newton, the same story will be happen. 12 Newton is there in right hand side, but in the left hand side, the frictional force is 10. Still, the object is not moving. So, what till sorry, the frictional force has the limit up to 10. So now the object will start to move. Now, Pulahal, now I'm going to draw a graph, right? Okay. You know, when I'm applying 1 Newton, the frictional force also 1 Newton. When I'm applying 2 Newton, We'll say like this way. 2, 4, 6, 8, 10, 12, 14. So when I'm applying 2 Newton, the frictional force also 2 Newton. When I'm applying 4 Newton, the same. The frictional force was 4 Newton. Right? When I'm applying 6 Newton, same. The frictional force also. When I'm 8 Newton. Now I'm going to draw the graph, right? I'm going to draw the graph. We'll mark the graph, right? When I'm applying 2 Newton, the frictional force also 2 Newton. Earlier, you may remember that, right? Here. When I'm applying 2 Newton, frictional force was 2. When I'm applying 5 Newton, frictional force was 5. When I'm applying 6 Newton, frictional force also 6. Okay. Same like that, I'm going to draw the graph, right? When I'm applying 6 Newton, the frictional force also 6 Newton. When I'm applying 8 Newton, the frictional force also 8 Newton. When I'm applying 10 Newton, the frictional force 10 Newton. Well, can anyone tell? When I am applying 10 Newton, what was the frictional force? When I'm applying 10 Newton, what was the frictional force? So 12 Newton. When I am applying 12 Newton, what was the frictional force? Anyone? Yes. Pardon? When I am applying 12 Newton, what was the frictional force? Whether it is 10 or 12?
10.
10. Very good, very good, very good. Yes, because you may remember, right? You may remember when I'm applying 9 Newton, frictional force was 9. But when I'm applying 10 Newton, the frictional force was also 10 Newton. Object still didn't move. Now what will happen? I'm going to increase the force. Now I'm going to increase the force up to 11 Newton. So when I am applying 11 Newton, the frictional force cannot increase up to 11 Newton because it has a limit, that is 10 Newton. So beyond that 10, the frictional force cannot be increased. So when I am applying 12
Excuse me,
Newton,
sir.
yes,
Can I get the tute? This lesson's tute
in the same
about the moment.
paper, the grade 10 and the
Yeah.
grade 11 students have the same paper, my dear.
No, the tute time.
Yeah, the you
Lesson
asked.
tute, theory tute.
Yeah, okay, okay, okay. I will be sending the details for you personally. Okay.
Okay, sir.
Right? When I am applying 12 Newton, the frictional force cannot be 12 Newton, that is 10 Newton. 13, when I am applying 13, the frictional force will be 10. So now we'll mark that term, right? When I am applying 12 Newton, frictional force 10. When I am applying 14 Newton, the same frictional force was 10. Okay. Now I'm going to mark. Now try to get the idea. Now try to get the idea. Earlier the object didn't move, right? Even I'm applying force. Yeah, I applied 9 Newton force, but the object is at rest. Even I'm applying the force, the object is at rest. So when the object is at rest, we have a frictional force, right? I'm applying 9 Newton, I'm applying 8 Newton, still the object is not moving because we have a frictional force. So this frictional force is called as static frictional force. That means the frictional force is there, the opposing force is there before the motion. Now the object is not moving, right? So before the motion, we have a frictional force that is called as static frictional force. Now I'm going to increase the force, right? 8, 9, 10. So when I am applying 10 Newton, what will happen, Pulahan? Whether they starts to move or whether they move or whether they be in rest. Anyone? Whether they will be at rest or they will be starts to move or whether they will move. Anyone? What will happen when I am applying 10 Newton?
At rest.
Pulahan,
Start to
try to
move.
get. When I am applying 10 Newton, the object will starts to move because we have exceed the limit, right? When I'm applying 9 Newton, the object will never move because 9, 9. But when I am applying 10 Newton, the object will starts to move because why? Look, when I am applying 11 Newton, they move. When I am applying 11 Newton, they move. That is a separate case. But when I am applying 10 Newton, they just starts to move. So at that point, where the object just starts to move. That is called as limiting frictional force. Limiting frictional. So earlier, before the motion, that is static frictional force. Now, limiting frictional force after after the object starts to move. This is called as dynamic frictional force. Now, try to get the idea. Before the object starts to move, that will be static. Before object starts to move, that will be static frictional force. And after the object starts to move, that is called as dynamic frictional force. And the object, when the object starts to move, after the motion, that is dynamic. Before the motion, that is static. When just begins to move, that is limiting frictional force. So there are three types of frictional force, right? Static, limiting, and dynamic. Static means before the motion. Before the motion. Before the dynamic frictional force means after the motion. After the motion means while the object is moving. After the motion. Limiting frictional force mean when the object just starts to begin. Just starts to begin. Just starts to begin. Did you get that idea here? When I apply 6 Newton, the object is at rest. So static. 7 static. 8 static. 9 static. 10 limiting. 11 Newton. When I am applying 11 Newton, now we have a frictional force. That is dynamic frictional force. When I am applying 13 Newton, the object starts to move, right? It will starts to move. So dynamic. Now you may have got
So
the
the sir, I think the maximum point of the static frictional force is limited frictional
yeah,
force.
yes. We can say the maximum static frictional force. That is also called as limiting. Yeah, very good. That is also we can say like that. Yes. You can see static frictional force started to increase. Right here, you can see that graph. Static frictional force started to increase 2, 4, 6, 8, 10. So this maximum static frictional force, that is called as limiting. And then after we will have the dynamic frictional force. So according to that one, can anyone tell me the answer for this one? Object kept on a rough table, the order of the frictional force. Anyone? The order of the frictional. Pardon?
This one.
First one, very good. Khadija and Atik, very good. That is the answer, very good. Zainab, very good. Yes, okay. Now, under the question number 4, we may have a gap like this, right? So within this gap, draw the graph. Right? There's a small drop, right? There's a small drop here. This is called as static. Before the motion. And here limiting static friction. Limiting friction. Within the paper itself, we can mark that term, right? Limiting friction. And here this is dynamic. Dynamic friction mean, what does it mean, plural? Before the motion or after the motion? Anyone?
The motion.
After the motion. So answer will be first one. The graph is needed for you, right? We did this question last. Yeah. Yashita, this is the thing, my dear. Last week, not yesterday. Last week, I had discussed this question, and today's session we are going to cover all the question related to the friction. So that's why I revised all these things. Okay, here these are the questions that we are going to discuss today. Here, question number 4, 18, 19. These are the questions that we are going to discuss today. So if you want to discuss this question, we must have an idea, no? So that's why I explained all the things related to the friction. Now directly I'm going to discuss all the questions, because if not, I won't explain one for all the questions. Okay, that's why I selected all the questions. I have selected the questions, and now I'm going to discuss all the questions at once. I hope that we may have finished writing the forces, right? We'll move to the next part. Okay. Shall I, Bilal? Shall I move for the next part? Fine.
Okay, sir.
Now, related to the frictional force, how to increase the frictional force and how to decrease the frictional force. Bilal, you know, in the machineries when the surfaces are rubbing each other, for example, just take a hand like this. So if you're rubbing your hand like this, what will happen, Bilal? Automatically the heat energy will be produced. So why the heat energy is produced? When you're rubbing your hand like this, the frictional force is produced. Because of the frictional force, the heat is produced. So the engine become heat. So you may have understood the frictional force is not a good thing. It is a bad thing, right? It is a disadvantage. So now I want to reduce the frictional force. So there are some techniques, there are some methods to reduce the frictional force. Just try to get the idea. If the surfaces are smooth, they will be moving easily on one another, right? But if the surfaces are rough, then now what will happen, Bulan? The both surfaces will be locked each other. And look, can you imagine here? In the tar road, you can see the surface is rough. So that's why the frictional force is very, very high. We will never slip down. We will never ever slip down in the tar road. We may fall down, but we will never slip down because it has a rough surface. But in the ice, what will happen? We will be slipped down because the surface is smooth. So in the engines, what happened, Pulahal? The surfaces are rough. So because of the rough surface, what happened? The engine will make the heat energy. So what will happen, Pulahal? We want to make the surface smooth. Look at the picture here. When the surfaces are rough, what will happen? The frictional force will be high. When you are making the surface smooth, the frictional force will be reduced. So, in the exam, they will ask, how can I decrease the frictional force, or how can I reduce the frictional force? So, the first technique, making the surface smooth. Second one, applying lubricants. Just imagine, well, in the engines and all, we will be applying the oils, right? Why we are applying the oils? Because when you are applying the oil here, the two surfaces will be slip easily. Earlier, when you are rubbing the hand, you may have felt the heat energy. But when you are putting the oil and when you are rubbing the hand, you will never feel that much of heat energy, right? The two surfaces will be easily slip down. So as a look, when you're using the lubricant, when you're using the oil, the frictional force will be reduced. And third one, putting the ball bearings here. When you're inserting the ball bearing, what will happen? This surface can easily rotate along this surface. Am I right or wrong? Both the surfaces will be rotate easily with the help of ball bearing. So these are the techniques to reduce the frictional force, because they cause us a disadvantage. So we want to reduce the frictional force by making the surface smooth or polishing the surface, right? Second one, applying lubricants. Third one, inserting ball bearings. And Pulahal, now advantages. Earlier we were discussing the disadvantages and we were reducing the frictional force. Am I right or wrong? Earlier we were reducing the frictional force. We were discussing the disadvantage and we reduced the frictional force. Now advantage. Pulahal, if I want to walk, I need the frictional force. Look at the picture here. I'm applying the force here, and the frictional force will apply the opposing force. So frictional force is needed. If the frictional force is not there, we will be in the same place and we will be running like. Have you seen, recently the video was viral. There was a deer that stuck on the ice surface. Right? What happened? There was a deer in the surface like this, right? Here in a polar region, the deer was here, right? And the person is going there to save that deer. Then what happened? The deer tries to run, but he couldn't. He's running, but he is in the same place because he's afraid of the human, right? The human is actually he's moving there to protect that deer. But unfortunately, what happened? The deer got afraid of the human. He's running, but he couldn't run because why? Because there is no frictional force. So if there's no frictional force, we cannot move. We will be in the same place, but we will be running like this. We will be running like this, but we couldn't move because there's no frictional force. So we will be sliding on the same place. So if we want to run, if we want to move, we need the frictional force. Second one, in the tires here, you may have seen the grooves, right? So these grooves helps to make the contact with the road. So when the tire and the road contact each other, the frictional force will be increased. Third one, the fourth one, in the coil ropes. Ulahal, can you say why we are using the coil ropes? You may have seen this one, right? The bucket and the rope, you will be putting that rope into the well and all. Those who have the well in your home, you may have seen this one. We will have the bucket here and we will be connecting the bucket to the rope, right? So in this setup, we will be using the coil ropes, right? Why we are using the coil ropes? Can anyone tell me, Pula? Start using the nylon rope. Why we are using the coil ropes?
Because they are very rough, sir.
They have the rough surface. Then only we can pull. We can pull that, the bucket or something. If we want to pull anything, for example, just say the vehicle has stuck into the mud. What will you do? You will be connecting this rope and you will be pulling that vehicle. So, if you want to pull that one, we must have a grip. If you want to pull that rope, if you want to pull that vehicle, between your hand and the rope, you must have a grip, right? So if you want to have a grip like this, the surface want to be rough, then only we will have a grip. Okay. So in the coil rope and in the braking system, this brake pad, the surface will be rough. Same like this. You may have the lizard, right? They have the grip. Can you see that again? The grooves, small grooves are there to increase the frictional force. So in the brake pad, we had the same grooves to increase the frictional force. You may ask, so even in our hand we had the grip, no? So can we walk in the wall and all like a Spider-Man? No, it is not possible, right? Because that is not that much enough. But we have a small grip. You can check that one. Place your hand in the table, right? Place your hand on the table. Just pull this like this. I have placed my hand on the book, right? I can feel small grip here. When I apply more force, it will be slipped down, but we have a small grip is there. Okay, because we also have the grooves like this, right? We also have a groove like this. So these grooves help in some places in the braking pad, in the tire, in the coil ropes, in the braking pad. If we have the grooves, then only the tire will be stopped, right? When I applying the brakes, the tire won't be stopped. So we must have the frictional force, a important, a useful. Okay. Now, Pulal, can you answer this question? The method of increasing the frictional force. Pardon? First turn, very good. First, because when you are polishing the surface, you may have seen that, right? When you are polishing the surface, the frictional force will be reduced. So easily slip down, right? Easily slip down. So when you are making the surface polished, the frictional force will be reduced. Please turn off your mics. Okay, that'll be fine. And here, next one, applying lubricants. Here, look at the picture here. Applying lubricants. They are also reducing the frictional force. Putting the ball bearings. they also reducing the frictional force. Okay. So all these things comes under reducing, right? Now in the box here, you can mark that one. How to reduce the frictional force? Reducing the frictional. How can I reduce? By polishing the surface. By polishing the surface. You can note down this one in your paper, right? Polishing the surface. And applying lubricants. Applying lubricants. And ball bearings. How to increase the frictional force? How to increase the frictional force, Pulahan? By making the surface rough. By making the surface rough. Make the surface rough. Make the surface rough. In the tire, in the coir ropes. Sir, I talked to the maths. What did he say, my dear? Mithun? Samiha, do Spider-Man have the grooves? Yeah. Wait, I will show a picture. Huh? Wait for a while. Huh? I will show you a small picture with that one, right? The theory class, I put that picture, but for the paper class, I removed that one. Wait for a while. I will show you. And Mithun, what did he say, my dear?
He said to join his classes, and he said he will do lessons by doing papers.
Yeah. Normally, he won't cover the theory and all. He covers the what? This by the paper. Yeah. Fine. Pula, have you finished writing? Samiha, wait for a while. I'll show you that one, right? I'm going to erase this one, right? Have you finished writing? Polishing surface. Okay. So in the paper, the answer will be this one. Etching the grooves. Etching the grooves. You may have seen the grooves right here. In the tire, in the slipper, we will have the grooves. Okay. And can I see that one here? In Spider-Man 1, right? I think he's the first Spider-Man for the 2K kids, right? So he will have the grooves like this. Can you see that one? It helps to move in the walls and all. You can check this one in the YouTube, right? You may have seen the video here. Okay. Let me have final. We'll move to the next part. The same question related to the frictional force. Okay. Can anyone answer this question? Can anyone answer this question? Read the question carefully and let me know, right? Because already we have discussed the graph and all. The graph part and all. You may have remember that, all right? Read the question carefully and tell me the answer. Yeah, they are applying 2 Newton. Still the object is in equilibrium. Yeah, they are applying 2 Newton force. But the object is not moving. What is the reason for that one? What is the reason for that one? Why the object is not moving? Because we have the frictional force that is also 2 Newton. Earlier you may remember, right? Earlier you may remember. I have shown you a picture like this, right? Do you remember? When I apply 2 Newton, the frictional force also 2 Newton. When I am applying 3 Newton, the frictional force also 3 Newton. Well, another question. What kind of frictional force is this? Anyone? Static or limiting or dynamic? Anyone? What kind of frictional force is this?
Static.
Atik, very good. Any others, Pulal? What kind of frictional force?
Static.
Static frictional force. Very good. Static frictional force. Yeah. Yeah, Vitum. He talks Sinhala very well, more than me. Okay, Vitum. I'm not that much familiar in Sinhala, but he is very familiar with the Sinhala. Rahamaniam. I had told me the answer. We'll check one by one. Okay. Here we are applying 2 Newton. the frictional force also will be 2 Newton. So the frictional force on the object is 2 Newton. That will be the answer. Within this gap, you can write here. Right, the static frictional force. Static, right? Static frictional force. Static frictional force is acting here. What is the magnitude of the static frictional force? That is 2 Newton. 2 Newton. And all the other answers are wrong. Frictional force on the object is less than 2. No, that is wrong. Frictional force on the object is... Pardon?
Fourth one.
Fourth one, Kelanga. Here they have clearly mentioned the object is at rest. So definitely the frictional force will be 2 Newton. No any doubt. Because they have clearly mentioned the object is at rest. Equilibrium. Move ahavilla, it didn't move. So no any doubts, Ati. Okay.
Thank you.
Right. So this is the explanation for that one. 2 Newton, 2 Newton. If they are given like this, 3 Newton, the object is at rest. That means the frictional force will be also 3 Newton. Okay. A very easy question. But we want to read the question carefully. That is the thing that they are expecting from here. Fine. Then question number 27. Same. Pulahal, once again, I want to tell you, read the question carefully. Right? I have given the support. I have given the data which are needed for this question. Read the question carefully and tell me the answer. Be careful. Please be careful when you answer the question.
Fourth one.
Pardon?
Fourth answer.
Fourth one. Fourth. We'll check one by one, right? And Zainab Raha. Yeah, we'll check one by one. I will check whether it is correct or wrong, right? Akif, Ilama, Akif, no, we'll check the answer, right? Illa, Pulahal, listen. Okay. Now I'm going to explain the question and be careful. Be careful, right? Listen here, Pulahal, listen here. Here, just say, in our previous example, we may remember that, right? When I'm applying 9 Newton, the object didn't move. When I'm applying 10 Newton, still the object didn't move. When I'm applying 11 Newton, the object moved. Am I right or no? You may remember that, right? When I'm applying 9 Newton, the object didn't move. When I'm applying 10 Newton, still the object didn't move. But when I'm applying 11 Newton, what happened? The object started to move. And you may remember, this is called as, Pula, what kind of frictional force is this that I have been boxed here? What kind of frictional force is this? Static or limiting or dynamic? Anyone? Static
Dynamic.
or dynamic? Oh,
Static.
illa. When the object starts to move, pardon.
Limiting.
Limiting. Yeah, limiting. You may remember that one, right? When the object starts to move, that is limiting, right? And here, this frictional force, that is called as anyone?
Dynamic.
Dynamic. Very good. And this frictional force, that is called as static frictional force. Now we'll read the question, right? Now we'll move to the question. Okay. Here, they have clearly mentioned when the force F is applied, the object is moving. That means he have applied 11 Newton. We'll take for example, we are taking like that. Okay, we can't say actually that is 11 or 12. For example, just say, because they have clearly mentioned the object is moving. No, object is moving. So he has applied 11 Newton. 11 Newton. Okay, 11 Newton. Okay, now we'll read the question. The force that causes the motion is less than F. the force that causes the motion. Well, in this example, can anyone tell what is the force that I want to give to move? What is the force that I want to give here to start the motion? Anyone?
10 Newton.
11.
10 Newton, 10 Newton. So here they have clearly mentioned that one, the force that causes the motion. That means they are telling about this 10 Newton, right? This 10 Newton. We'll put A like A for this one, right? So the force that causes the motion, that is less than F. Am I right or wrong? 11 Newton is here. So I am applying 10 Newton. So the A statement is correct. The force that is needed, that is 10 Newton. If I want to start this object, I need 10 Newton, but I have applied 11 Newton. So that's why the object is moving. So the statement A is correct. The force that causes the motion, that is 10 Newton. So that is less than F is 11 Newton. So the force that is needed to move that object, that is 10 Newton. So the 10 is less than 11. That is correct. Second one, the F means that is 11 Newton. Okay, wait. We'll erase this one and put in a proper way, right? 11 Newton. Right. The F is greater than the limiting frictional force. Already we have marked the limiting frictional force. Limiting is 10. Here we have applied 11 Newton. So the 11 Newton is more than the limiting frictional force. Am I right? Limiting was 10, right? So that is also correct. And static frictional force between two surfaces is less than F. Here, static frictional force. We can put B for this one. And we can put C for this one. Because the C statement said that static frictional force, that is static frictional force that is less than F. That is also correct. F is 11 Newton, static frictional force that is 9 Newton. So that is also correct. Dynamic frictional force is equal to F. This is dynamic, right? Dynamic is 10. We are applying 11 Newton. Both of them are same? No. Dynamic frictional force, we can put B for this one, right? So dynamic frictional force and the force that we applied, they are not same. So that is wrong. So the answer will be A, B, C. So most of you have sent me the correct answer, the fourth one, right? Very good. Very good, very good, very good. Okay. Well, I'm going to explain the same question once again. Just try to get the idea. If you didn't get the idea, look after the screen. There are three answers. Hishma B. Yeah. So how did you how did I took 11 Newton from the previous example? From the previous example, I told you a big story, right? A big story. When I started the class, I told you a big story. So that's why I took like that. According to your need, you can take any amount, any number, any values. But from that example, I explained. That is the thing, my dear. Who asked that one? Neha. Earlier, I explained with a big story. So according to that story, I'm going to explain all the questions. You can take another different story and you can put another different value. No any problems. But the answer will be the same answer. Sorry, Neha. Your question is this, right? Okay. Now only had joined. Okay. So it's okay. You can watch the recording for that one. Don't worry about that one, okay? Okay, now I'm going to explain the same question once again. Just look after the screen, right? Here, we're applying 9 Newton. The object is not moving, right? Because the frictional force also 9 Newton, no? Then what happened? We increase the force up to 10 Newton. From 9 Newton to 10 Newton, I increase the force. Then what happened? The frictional force also increased. Oh, shit. Object is not moving. Now what happened? Still the object is not moving now. So then I increase the force up to 11 Newton. But the frictional force, they cannot increase up to 11 Newton because they have a limit. That is 10 Newton. So now I'm going to name that one, right? I will use blue color for that one. This is static. This is limiting. This is dynamic. So we have named the frictional force static, limiting, and dynamic. Okay, now we'll move to the question, right? Here they have clearly mentioned the object is moving. That means we are applying 11 Newton. You may ask, you may ask, so how can you say that is 11 Newton? Because the object is moving. They have clearly mentioned, right? Read the question here. The object is moving, when the object move forward. So that means we have applied 11 Newton. So now we'll discuss the questions one by one. Statement A, the force that causes the motion. Well, I just say, well, statement A says that the force that makes the motion. Which force make the movement? Which force make the object moved? The 10 Newton, right? The 10 Newton, sorry, the 11 Newton, they only makes the object move. Okay, this 11 Newton is less than F. Am I right or wrong? Oh, sorry. The object in the 10 Newton force, this force make the object start, just begins to move. When I apply 10 Newton, the object just starts to move. So they are asking the force that causes the motion, that is 10 Newton. Yeah, okay, fine. The force that make the object smooth, that is 10 Newton. That is less than F. Am I right or wrong? F is 11 Newton. F is 11 Newton. Fine, already we have calculated. Not calculated. We have guessed the F is 11 Newton. The force that makes the object move, that is 10 Newton, right? So the 10 is less than 11. So the statement A, that is correct. Am I right or wrong? 10 Newton கொடுத்த நேரம் தானே மூவாக ஆரம்பிச்சது. That 10 is less than 11. Am I right or wrong? So the force that causes the motion, that is 10 Newton. So we can put A here. Am I right or wrong? The A statement indirectly mentioned this one. Okay, we'll discuss B. The F is greater than the limiting frictional force. Limiting, that is B, right? We'll put B here. Limiting frictional force, that is 10 Newton. You know, the 11 Newton is higher than the greater than the limiting frictional force. Limiting is 10. We are applying 11 Newton. So that is also correct. C, static frictional force. We'll put a C here, right? Okay. Static frictional force is less than F. Yeah. Static frictional force is 9. We have applied 11 Newton. F is 11 Newton, no? So that is also correct. Last one, dynamic frictional force. What is dynamic here? This is dynamic, right? We'll put D here. Dynamic, that is 10 Newton. That is equal to 11 Newton. F means that is 11. No. This is F, right? So that is not equal to F. Dynamic is less than 11 Newton, less than F. So that is wrong. So Pulahal, you can draw this diagram and you can mark all these datas. You can mark all these datas. You can mark all these datas. Dynamic, 10 Newton, D, A, B, C, D, F, all these things. But can you raise hand those who got the idea? Can you raise your hand those who got the idea? Can you raise your hand those who got the idea? Only 9, 11, 12, okay, 13, fine. Pulahal, if there are 14, fine, very good. If there are anyone that didn't understand the theory, please watch the recordings, okay? Because if I explain the same question again and again and again, it will be got bored, okay? And there was a comment today, right? Sahid and Orali in the classical, okay? He's very talented guy, right? Very, very talented. He got 30 marks in the exam, okay? But he's very talented, right? So he is telling like this. Because I was telling the same thing again and again and again. It was an issue for him. So same like that, you also feeling the same thing, right? So that's why I explained the question 2 times. So if you want the explanation 3rd time and the 4th time, you can watch the recording. I'm very sorry for that one, okay, my dear. So I think you have finished writing, right? Okay. Yeah, okay, yeah, I'm ready. Yeah, we'll face tomorrow, okay? Fine. We'll move to the next part. We'll move to the next part. Shall I move?
Bro, it's very wrong, bro.
Pardon? Yeah, you want to draw the diagram. You want to draw. There's no need to draw the humans and all. Just mark that one. I think in question number 27 we don't have the space, but it's okay, right? You can mark this data in under the near to the 27. Question number 27. Shall I move to the next part? Notes to mark. Notes. Notes means I couldn't understand. I know what's here. What did you say, my dear? Notes to mark. That means no. I told you to mark all these data. That here 9 Newton, 11 Newton. We'll move to the next part, right? Okay. Question number 33. Same thing. Same thing. That how to increase the frictional force and how to decrease the frictional force. We have discussed earlier. You may remember, right? How to increase and how to decrease. We have written all these things. Okay. Same idea. Question number 38. Can anyone tell me the answer? Here they are asking how to increase the frictional force. Akif. Akif. No, check the answer. Check the answer. Check the answer. Check the answer. How to increase the frictional force. Just read the question, right? You can put the answers in the chat box. If you have find the answers. Very good. Zainab Raha. Raha Mariam, sir. Raha Mariam. Akif, very good. Yes. And Muhammad Hudaybi. Yeah, very good. Yes. And Hubayb. Very good. Yes. Hudaybi, we have the recording for the previous session. Katayam Paranga, right? Shahid Ahmad. Very good. Very good. Very good. And Rukaya. Okay, very good. And Swastika. Very good. And Hanim. Yeah, very good. Yes. And Neha, very good. Yeah, Hudayb, yeah. Ishma, very good. Yes, done. Done. Right. Okay. Artik, right. Very good. Yes, that is the answer. We'll discuss the questions, Bilal. We'll discuss the questions. Khadija Fahmi, yes, very good. That is the answer. You may remember, Bilal, last class we had, sorry, not last class, early, just before we had discussed how to reduce the frictional force and how to decrease the frictional force. Pulal, you may remember that regarding the coir ropes and all, I explained that one, right? Coir ropes, we have a rough surface, so they increase the frictional force. Here, so using a rope, so that is increasing the frictional force. Applying sand, Pulal, just say, I think you are not familiar with this one, but in the railway and all, when you are applying the sand here, the surface will become rough, right? So what will happen when I apply the sand here, the surface become rough. So in the hill country and all, if the train wants to move like this, we must have a good high amount of force, right? So we will be applying the sand between the rim, between the tire, not tire, the metal between these railway tracks to increase the frictional force. In the carom board, we are applying the powder. Why we are applying the powder in the carom board? Can anyone tell me the answer? Why we are applying the carom powder?
To reduce the friction.
To reduce the frictional force. Very good. To reduce the frictional force. Not to increase the frictional force, right? In the carom board, we are applying the powder to reduce the frictional force. So we can definitely say the option B, that is wrong. Applying boric powder in the carom powder is to reduce the frictional force. So if the B is answer, we can cut all these things. So directly the answer will be first one, A and C. Okay, I think this is not that much hardest question, right? Yeah, Umar Akil, very good. Mithun, okay, very good. And another one, I don't know the name. Aisha Hani. Okay, Aisha Hani answer is wrong. And question number 44, same. Strategy to increase the frictional force. Already we have discussed that one. How to increase and how to reduce. And we have written what are the methods to reduce the frictional force and what are the methods to increase the frictional force. Can anyone tell me the answer here? to increasing the frictional force?
Second.
Second one, very good. Second one, very good. Yes, okay. Yeah, Umar Akil and Akif, very good. And yeah, Shahid Ahmad, very good. Yeah. Hubayb, Hubayb. Man, lubricants pota, Thambi. Lubricants pota. When you are applying the lubricants, my dear, what will happen? The frictional force will be reduced. Hubayb, just say, yeah, when you apply the oil. Why you are applying the oil, right? In your hands, normally when you are putting the oil in the head and all, you will be applying the oil, right? Why? When you are applying the oil, the frictional force will be reduced. That's why you are using the oil, right? In the hand. So here, when you are using the oil, the frictional force will be reduced. Okay, but they are asking to increase. So that is wrong, right? First one is not the correct answer. Okay, fine. And Khadija, okay, done. Okay, very good. And Hudaybi, okay, very good. Vitham, okay, done. Very good. Neha, done. Okay. Swastika, done. Okay, more answers are there. We'll discuss one by one, right? Yeah, Zainab Gaha, done. And Sheba, okay, done. Very good. Yes. Okay, in the grooves, in the tire, we are etching the grooves to increasing the frictional force. So that will be the answer. Third one, fourth one, no any, nothing connection that one, right? That is increasing the pressure that you may have learned in your grade 9. That is related to the pressure, not related to the friction. Okay. And question number 53. A very good question. If you have the total idea, then only you will be able to answer this question from the graph. You may remember the graph, right? You may remember the graph. You may remember the graph. Just revise the graph and come to this question. You may have drawn the graph, right? For question number here. What's the question number for this one? Question number 4. For question number 4, we have drawn the graph like this. So from the graph itself, try to answer the question. Yeah, very good, Akif. Very good, mashallah. Very good.
So
Okay.
the P is increasing from 0.
The P means that the force that we are applying. Yeah, that is increasing from the 0. Yeah. So they be very good. Yes. Umar Akif, very. Yeah. Turun kastamilla bola. But yeah. Fine. Okay. You have to tell me the correct answer. Very good. Yes. Yashit, very good. Yes. That is the answer. Yashit. Yes. Khadija for me. No. Khadija for me. Abdi nala adavasi. This is a past paper question. This is a past paper question, right? I Neha done. Swastika, check the answer, my dear. Shahid. Okay, whatever. Very good. With very good, yes. And another answer, Hubayb. That's meeting we'll check one by one, don't worry. Yeah, Hubayb, I think this is a first class, right? Within, yes, very good, very good, very good. Within, your answer is correct.
ಸರಿ ಮೊತ್ತವಾಗಿ ಹೇಳಿ. Bunai, please take.
Right, okay, yeah, your answer is correct. Okay, fine. We'll move to the next part. We'll move to the next part. Here, just try to get the idea. Here, in the frictional force, I have explained like this. You may remember that, right? Look at the picture here, right? Come along with me, right? If the friction, when the force applied is 0, the frictional force also will be 0. When I am applying 1 Newton, the frictional force also will be 1. When I am applying 2 Newton, 2, 3 means 3, 4 means 4, 5 means 5, 6 means 6, 7 means 7, 8 means 8, 9, 9, 9, 9, 9. When I am applying 10 Newton, the frictional force will be 10. When I am applying 11 Newton, the frictional force will be 10. When I am applying 12 Newton, the frictional force will be 10. So, you may remember the graph. The frictional force will increase from 0, here the frictional force is 0, it will be increasing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and there will be a small drop, and it will have a remains in a uniform value, constant value. So now check the answer. Is there any answer like that? Is there any answer like that? Increase gradually from 0 to maximum value. 0 to a maximum value. Okay. And slightly decreases and become constant. At that time you may have think like that, so the graph is not in the syllabus, then why you are explaining regarding the graph and all? The graph is needed. There is a past paper question in 2018, the essay question, the structure question is there. They have given the graph and they have asked the question. Already we have written the graph, it's okay, once again யார் சார் அது phone பண்ண சொல்லுங்க, off பண்ண சொல்லுங்க please. Yeah, I offed it many times, but I don't know why they are owning again and again and again. Right? Okay, it's okay, fine. So here I have already we have drawn the graph, right? So once again we can draw the graph like this, and we can name. Can anyone tell what is the name for this frictional force? Anyone?
Static.
Static. Very good. Static. Okay, very good. And here this one?
Limiting.
Limiting. Very good. Very good. And this one?
Dynamic.
Dynamic. Very good. So static, limiting, and dynamic frictional force. And don't do anything.
So there was another word for dynamic. I can't remember that.
Kinetic.
Okay.
So from the graph itself, you can answer the question. You may have realized the importance of the paper class, right? You may have studied the theory, but the question will be different, right? So don't miss the paper classes, right? The paper class will be very effective when you are doing the exam paper. For example, just say, now you have the total idea regarding the equilibrium. Yesterday we have learned. And you have the total idea regarding the displacement time graph. Yesterday we have discussed. And you may have the total idea regarding the moment, the turning effect of force. Now you have the total idea regarding the frictional force. Did you get the idea? So like this in each and every class. So yesterday the class was 2.5 hours, and today just try to get the idea. The Thursday the time earlier we were starting the class at 7 o'clock. But this week I told you that the class will be started at 6:30. But no one was there in the class, so that's why I started the class at 7 o'clock. So next week the class will be at 6:30 in the Thursday. Okay. So Wednesday 2 hours, Thursday 1.5 hours. So it will be completely enough for the paper class, right? So within 2 weeks we can cover the physics, chemistry, biology like that. Okay. We'll move to the next question. Shall I explain the next question, Bilal? Have you finished drawing the graph? And have you finished marking all these things? Can you raise your hand? Those who have the printout with you. Those who have the printouts with you. Can you raise your hand? Those who have taken the printout. Okay, 1, 2, 3. Yeah. Any others? Okay, 8, 11. Okay, only 11 of you have the printouts, right? So Pulahal, please take the printout. Without the printout, the paper class will be not effective. That is it. Without the paper class, so without the printout, the paper class is not that, because where will you write all these things? Where will you write all these things? We want to write this explanation, right? Then only when you're moving for the exam, for example, just if the exam is tomorrow, you can revise all the theories related to the physics by using the paper. So you must have the hard copy with you. Without the hard copy, nothing useful for you. Okay. Yes, okay. Fine. Now, Pulahal, I'm going to explain to find the resultant force. Okay. Here, the resultant force. Still, we haven't studied resultant force, right? The next, the fifth heading will be resultant force. So we'll discuss that question later. Okay. Question number 54. Question number 54 will be discussed later. It is related to the frictional force or resultant force. It will be discussed later. But the answer will be like this. The answer will be P minus F. Sorry. X minus F. X minus F. This will be the answer. But those who don't have the idea related to the resultant force, don't worry. I will be explaining that one later. Don't worry. Yeah? Don't worry. Don't worry. Akif, it's okay. It's okay. It's okay. If you have done the mistake, it's okay. Fine. It's okay. Sir, can I know how to get the paper? Imara Infas. You can get the paper from the group, my dear. Are you in the group? In Inara Infas, are you in the group, my dear? Have you joined the group? No. Yes, okay. Then you can put a message. I think that today only have joined or something, okay? Because okay, you have joined tomorrow. Okay, okay. I will be sharing the paper for you personally. Put a personal message for my number, and all the explanation will be there in the YouTube. Okay. So here, this is our third session. So second session. The first session was held yesterday. I will be sharing the PDF with you. Don't worry. Yeah. Okay. Fine. Question number 5. The same thing. Same thing. Can anyone tell me the answer? By applying the lubricants. By applying the lubricants, what are you changing? What are you changing here? By applying the lubricants. Anyone? Yeah, okay, very good. Yes, your answer is correct. Yes. Anyone? Okay, Aisha, very good. And Raif, okay, very good. And Yashita, okay, very good. Inshallah. Rukaiya, done, very good. Okay, fine. And Hubayb, very good. Okay. Umar Akil, very good. Yes. Ishma, very good. Yes, done. இல்ல. We'll check, don't worry. ஐநேஹா கவலை பண்ணாம. Be happy, we'll check that one. Yeah, Fawzul, very good. Yes, okay. We'll check, my dear. Listen here. There are 3 factors affecting the frictional force. How many factors are there? There are 2 factors affecting the frictional force, and there's a practical for each and every practical. There's for each and every factor we have the practical. Just try to get the idea. If the surfaces are smooth, the frictional force will be very, very low. We will be easily slip down. If the surfaces are rough, now what will happen? If the surfaces are rough, what will happen? The frictional force will be high. So the nature of the surface. If the nature is smooth, the frictional force is high. If the surface is rough, if the surface is smooth, the frictional force will be low. If the surface is rough, the frictional force will be high. First factor regarding the nature. In the exam, they will ask what are the factors affecting the frictional force. Second one, regarding the perpendicular reaction. Easy. Don't make it hard. Just imagine, just imagine. You are here, right? We have a table like this. You are going to pull that table. And now what happened? You are going to stand up on the table. Now what will happen? Will it be easy to push that table, or whether it will be hard to push the table? Earlier, if you are not there in the table, if you are not in the table, we can easily move the table. But when you are climbing on that table, what will happen? It will be a difficult task to move that table. And just imagine if 2 of you are in the table. Now what will happen? It will be more difficult to move the table, right? So when the weight increases, weight means you are going to climb in, you are going to sit on that box, right? So automatically the weight increase. If the weight increases, what will happen to the perpendicular reaction? Perpendicular reaction also will increase. Now you may ask, so what is perpendicular reaction? Then what is the relationship between the weight and the perpendicular reaction? Yeah, it will be discussed under the Newton's law. Here we have another heading under the 8th heading is there, right? Regarding the Newton's law of motion. In that part, I will explain what is the relationship between these 2 things. Don't worry, okay? So if the weight increases, perpendicular reaction also increases. So what happened? Frictional force increases. That's why you felt difficult to push the table. Earlier the box was there, you were easily pushing the table. When you climbed on that table, then you felt difficult to push that table because the weight has been increased. So the frictional force also has been increased. So the perpendicular reaction also a factor. And the surface area, just memorized, the surface area is a not a factor, is a not a factor, not a factor, not a factor, not a factor needed with the frictional force. So these are the three factors that are affecting the frictional force. Now come to the question, right? By applying the lubricants, what is the factor that you are changing, Pulan? Are you changing the weight? No. Are you changing the surface area? No. Are you changing the perpendicular reaction? No. Perpendicular reaction means you want to sit down, you want to climb on that vehicle. Not like that, right? We are applying the oil because we are changing the nature. Before applying the oil, the surfaces were rough. So you feel heat energy. Frictional force is high. When you're rubbing your hand, the surfaces are rough. So you feel higher amount of frictional force. So it produces the heat energy. But when you're applying the oil, you're changing the nature. Did you understand, Pallav? Did you understand? So from this question, we have learned two things. First one, what are the factors? What are the factors, Pallav? What are the factors affecting the frictional force? First one, the nature of the surface. We have learned a new thing, right? Second one that we have learned, perpendicular reaction. What is perpendicular reaction? That is weight. You may ask, so what is the relationship between the weight and the perpendicular reaction? You may have a doubt like that. Am I right or wrong? It's okay. I will explain that one later. Don't worry. Yeah. Now just try to get the idea. Perpendicular reaction. We'll put PR, not Pradeep Ranganathan. Okay, that is perpendicular reaction. Now the third one, surface area, it does not depend on the surface area. You can put surface area and we can cut that one. Okay. Now, why we are applying the oil? Are we changing the perpendicular reaction? No. By applying the oil, we are not changing the perpendicular reaction. So the first one and second one, that is wrong. And by applying the oil, we are not changing the surface area. By applying the oil, we are changing the nature. Earlier it was rough. Now when after applying the oil, it will become smooth because the two surfaces will be easily slipped down. You are familiar with that one, right? There's nothing to explain there. Okay. Everything. And Zainab, okay, fine, okay. Now we'll move to the next question. They are related to the resultant was, wait for a while, okay. Pulahal, those who are join the class for the first time, just try to get the idea. Moment of force, we have discussed all these questions related to the moment of force. I will be putting the group, right? What are the questions related to the moment? And then after we discussed the questions related to the displacement time graph. These are the three questions related to the, out of 52 questions, these are the questions related to the displacement time graph. And then after we discussed regarding the equilibrium. So these are the 8 questions related to the equilibrium. Already we had discussed in our last class, right? Yesterday. And today we have discussed related to the frictional force. How many questions? 4, 5, 6, 7, 8, 9. So we have discussed 9 questions related to the friction. We will do a quick revision. Okay, fine. First one related to the order of the frictional force. We have written that one like this. We have drawn a graph, static, limiting, and dynamic. You may remember the graph, right? Static and limiting and dynamic, right? Static, limiting, and dynamic or kinetic. Second one, we discussed how to increase the frictional force and how to decrease the frictional force. So these are the techniques to decrease, making the surface smooth, polishing the surfaces. and applying lubricants, using the ball bearings. And advantages to increase the frictional force, we have the grooves in the tires, we have the grooves in the shoes, and we have the grooves in the surface is rough. So we will have a high amount of grip here, and the braking system fine. And then after we discussed a question, right, regarding the static frictional force. And then after we discussed regarding the all the type static, limiting, and dynamic, a standard question is there. Okay, 27 question number 27 was a standard question, right? Question number 33 same, related to the increase in the frictional force and reducing the frictional force. Question number 44 same, reducing the frictional force and increasing the frictional force. Question number 53, a very good question, it was a past paper question related to the graph. It was increased and it has a slightly got decreased and a constant value. Based on the graph, we answer this question. Question number 54, we didn't discuss this one because we must have an idea related to the resultant force. Question number 55, same, the frictional force, but in this question we have learned what are the factors affecting the frictional force. What are the factors? Can anyone tell me, Pula, what are the two factors? Anyone? There are two factors affecting the frictional force.
Nature of
Nature of the
constructing.
surface. Second one,
Perpendicular reaction
perpendicular reaction. Very good, Swastika and Aarti. Yeah, perpendicular reaction. Perpendicular reaction. Yes, okay. And third one, I said that in the surface area, it does not depend in the surface area. So directly we can answer this question, not surface area. Here we are applying the oil not to decrease the weight or normal action. Nothing will happen to that one, right? Only the nature will be different. Okay. And the remaining part regarding the resultant force, it will be discussed in our next class, in our next Wednesday's paper class. Okay. So please don't miss the class on Wednesdays and Thursdays. So we'll conclude the class. سبحانك اللهم بحمدك أشهد أن لا إله إلا أنت أستغفرك وأتوب إليك. Salam alaikum wa rahmatullah and good night. Have a nice day. We'll meet in our next class.
Have a nice day, sir.
Okay. Okay.
Sure.